this video, we will look at the vocal organs and describe the major anatomical structures involved in the production of speech. We will start with the presentation of the major organs of speech. The next step is to comment on their role in articulation. Later, a more detailed description of the vocal tract will be given. The major vocal organs consist of the lungs, the left lung and the right lung, the diaphragm, the trachea, the larynx, the pharynx, the nasal cavity, and the oral cavity. The lungs. The role of the lungs is that of the initiator, i.e., they are the source of airstream in most languages. The lungs are not capable of movement themselves, but they expand and retract thanks to the movement of the diaphragm and the swinging of the rib cage. The direction of airstream, there are two types of direction. The first one is the egressive airstream. The air comes out of the mouth. This is by far the type of airstream which is used by most languages. The airflow can also be ingressive, that is, it flows into the mouth. There's also the pressure of airstream. We generally talk about the fortis type of airstream. Here, a muscular effort needed to drive the air out of the body is substantial. For example, in sounds like s, sh, and h, there is a substantial muscular effort. The second type of pressure is the leanest one. Here, little muscular effort is needed to drive the air out of the body. This is what we have in sounds like z, j, and r. The larynx. The larynx is that part of the vocal tract that comes immediately on top of the trachea or the windpipe, and it is coextensive with it. The larynx contains the vocal cords, also called the vocal folds, made of elastic tissue and capable of movement. The larynx also plays an important role in the initiation of the glottalic airstream mechanism. The major vocal organs also contain the pharynx and the nasal cavity. The pharynx. The role of the pharynx in the speech sounds is that of resonance. The pharynx is also a place of articulation for some sounds like h and these sounds are called pharyngeal. The nasal cavity. The nasal cavity has a fixed shape which is suitable for resonance. In speech sounds, the nasal cavity is either available, in which case the sounds are nasal, example n, m, and ng, or is unavailable, in which case the sounds are oral, example t, d, p, b, and k, g. We move on now to the details of the vocal tract. Here we can see the vocal cords. Here we have the glottis, which is the opening between the vocal cords, the epiglottis, the back of the tongue, the blade of the tongue, and the tip of the tongue. We now move on to the roof of the mouth, and here we have the uvula, the velum or the soft palate, the hard palate, and the alveolar ridge. Then we have the tulips and the teeth. The vocal cords, these are elastic tissues placed in the larynx. They are joined at the front of the larynx at the level of the Adam's apple and are capable of movement horizontally. The glottis is the space between the vocal cords. Now, the vocal cords can be capable of a certain amount of action. For the sake of articulation, the vocal cords can assume three configurations. They can be open. In this configuration, the airflow from the lungs is unimpeded. It accordingly does not set the vocal cords into vibration. When the vocal cords are not vibrating, the sounds articulated are voiceless. Examples of voiceless sounds are p, f, k, and ch. The second configuration of the vocal cords is a closed one. The vocal cords are brought into firm contact in this case. As long as they are maintained this way, there is no vibration. When they are released, the glottal stop is articulated. The vocal cords can also be narrow. When the vocal cords are close to one another, the airflow sets them into vibration. The sounds articulated are voiced, and here we have the examples of the sounds b, v, g, and j. Now we move on to the roof of the mouth. The roof of the mouth can be divided into three parts starting from the back. The soft palate, or the velum. The velum is capable of assuming two positions. The velum can be lowered, in which case we talk about a velic opening. The nasal cavity in this case is available. There is some air in the oral cavity, but it is blocked at a given point of articulation. The only passage available for the air is the nose. Therefore, the sounds articulated are nasal sounds. The velum can also be raised, in which case we have a velic closure. The nasal cavity in this case is shut. Accordingly, the only outlet available is the mouth. The sound articulated this way is called an oral sound. The velum also serves as a place of articulation in sounds like k, g, h, r, and ng. The velum also plays a major role in the initiation of the velaric airstream mechanism. Now the hard palate, since this part of the roof of the mouth is not capable of movement, its role is mainly that of a place of articulation. The same thing can be said about the alveolar ridge, which role again is mainly that of a place of articulation. We now move on to the tongue. The tongue is a very agile organ of speech. It plays a very important role in articulating both consonants and vowels. The tongue is generally divided into parts for the sake of phonetic description. These parts are identified on the basis of their position with respect to the roof of the mouth. We have the back, which corresponds to the velum, the blade, the part immediately under the hard palate, and the tip. When the tongue is at rest, this part is immediately below the alveolar ridge. Tongue action in vowels. The tongue can be raised to various levels. The difference between the vowel E, for example, and E is one of tongue height. Different parts of the tongue may also be responsible for the articulation of the different vowel sounds. The difference between the vowel E and U is based on a part of the tongue involved, the back in U and the front in E. Tongue action in consonants. Different parts of the tongue are involved in consonants. In the sound T, the tip of the tongue is used. In a sound H, however, it is the back of the tongue which is involved. The tongue can also assume various positions. One special case is the curling of the tongue backwards so that its underside faces the roof of the mouth. This is the case of the retroflex sounds like R. The lips. Lip action consists of spreading the lips, rounding them, or maintaining them in a neutral position. What matters in speech sound articulation is whether the lips are rounded or unrounded. We start with lip rounding. With vowels, vowels can be distinguished on the basis of lip rounding. The vowel A and the vowel A are identical in every respect except lip rounding. In consonants, lip rounding is involved in labialized consonants like Q. There's also labiodentalization, in which the lower lip is involved in labiodental consonants like F or V. Now we move on to the teeth. The teeth are generally a place of articulation. They interact with the tongue in dental sounds. The teeth also interact with the tongue in interdental sounds, in which case the sounds we have contain the tip of the tongue protruded between the upper and lower teeth. The teeth also participate in displaced articulations like labiodentalization, in which case the lower lip is made to move backwards to interact with the upper teeth. Let's now summarize what we have seen so far.